Hello, my name is Miguel Aguilar. I'm an instructor here at St. Philip's College, and I'll be guiding you through your final exam review for Math 1342 Elementary Statistics. Okay, let's dive right in. So I'm going to go ahead and share my screen so that you guys can see what the review looks like. Remember, your review is in ALEKS. Okay, so we should just be able to click on Start and look at the questions here. So there are 40 questions total. You can skip around, but what I'm going to do in these videos, a series of videos, is I'm going to tackle 5 questions at a time and make my way through the entire review. So if you need to, you can fast forward through the things that you understand and maybe just really focus on the things that or the questions that you're having difficulty with. Okay. So this first question is asking us, determine whether the data are qualitative or quantitative. Okay. Qualitative or quantitative. Gender of movie stars. So I'm going to go ahead and share my screen here so we can take a look at what I'm writing down. Okay. Now remember, this is a math class, so being able to show your work even for the most trivial problems is essential. So even if you don't think that there's work to show, you still want to make sure your instructor knows how you got the correct answer. So this question was asking us about something in particular. It said that we wanted to know whether the gender of movie stars is either qualitative or quantitative. Okay. So whenever I learned these vocabulary terms early on, I always thought the qual here kind of makes you think of quality. Quality is a subjective measurement or a subjective label that you give to something. Okay. It's not a numeric piece of information. It is not something that you count. It's not something that you measure. Okay. Quantitative is like quantity, right? And again, quantity indicates that you can either count or measure that variable. Okay. So because we're looking at gender, and we don't typically think of gender as a numeric variable. It's not something that you count. It's not something that you measure, but the categories themselves are just labels. Typically, we think of a gender binary as male or female. Sometimes there are other sex conditions like intersex. But in any case, that's just going to be a discrete label, not something that we count or measure. Okay. So that tells us that we should be looking at a qualitative variable. Okay. So we'll pop back over here to ALEKS, select qualitative. Again, that's just strictly a vocabulary word that you have to memorize. So we'll hit check and we'll get that green check mark that we love to see. Okay. Now let's go ahead to question number 2. Question number 2 is a little bit more involved. Okay, it says use the frequency distribution to find 3 things. The class width. I'm going to go ahead and write that down. And I'm going to write down the formula for class width, which is the range divided by the number of classes. Okay. And then we want to round that up. Okay. Then we need to find the midpoint of the first class and then the class boundaries of the first class. Okay. So let's see. Well, it looks like they haven't given us raw data here. This is already a grouped frequency distribution. So I'm going to go ahead and switch over here. Grouped frequency distribution, i.e. not raw data. Okay. So maybe if I just annotate on the screen, this will make some sense. Here we go. So first, our data is already organized into discrete classes. and the frequency of each of the data values that fall in between those class boundaries has already been listed for us, okay? So realistically, to find the class width, we don't need to use a formula to calculate anything. Excuse me. We just need to look at the difference between the lower class boundary of the first two classes. And they should be the same for every one. So if we look at the difference here, remember that in mathematics, we think of the difference as being a subtraction problem. And that's just 46 minus 40, which should be a distance of 6. Okay, so that's our class width. Okay, now it's asking for the midpoint. So let me go ahead and change colors here. Let's see how to do this. The midpoint of the first class. Okay, there we go. So remember, the midpoint is given by a very simple formula. So I'm going to type this on the screen. Midpoint is equal to the lower boundary plus the upper boundary of your given class, and they want us to look at the first class, and then we're just going to divide that by 2. It's literally the same as taking the average of those two values, okay? So for this first class here, we just need to take 40 plus 50, sorry, 45. And then whatever we get there, we can divide by 2. Okay. So I'm going to switch over to my document camera so we can take a look at that. So part B was the midpoint. And we can just use the formula that I gave you, the lower boundary of that class plus your upper boundary, and then divided by 2. Okay, so we said that was 40 plus 45. Remember, that is always a plus. Then divide that by 2. And if we throw that in our calculator, 40 plus 45 should come out to 85. Divide that by 2. We get 42.5. Okay, so this should be our midpoint. Now, the last part of the question was asking for the class boundaries of the first class. Okay. Well, if we have our class endpoints that they were already given to us, 40, 45, then remember, we have this rule where basically, since those are in terms of whole numbers, like 40 and 45, then we're just going to subtract or add 0.5 to each of those class endpoints so that we can get the boundaries. Okay. So if we just switch back, our class that we're looking at, the first one is 40 to 45. Then if I just subtract 0.5 from this one and add 0.5 to that one, then we should get 39.5 to 45.5. So this should be the set of class boundaries for that first class, okay? So we found that based on the work that we did before, that our class width was equal to 6. We found the midpoint, and now we have our class boundary. So once we've done all that work, we can just look at the options that they give us, since this is multiple choice, and just make sure that we hit all the main things, that we correctly select the answer. So width at 6, that's going to eliminate the last two. So we're just looking at these first two. And then we have a midpoint of 42.5. They're both 42.5. But then our boundaries are 39.5 to 45.5. So that first option should be correct. We can check it and see we get a green check mark. Okay. Let's go to the next question. Okay. Excuse me. Now, this one's going to be a little bit more involved, okay? Because they've given us a whole raw data set. Okay, so if you look and just count how many data values did they give us? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. There's a total of 5 times 8, which is 40 data values here. Okay. So the problem says energy used by plasma TVs. 40 plasma TVs were tested, 40 data points, and the number of watts per hour they used while running for 4 hours per day was recorded. Okay, so this data represents the wattage that was used while running for 4 hours, these TVs. Construct a frequency distribution for the data. Use 6 classes. Okay. So first of all, whenever you're given a raw data set, you want to go ahead and throw that data into your calculator. Okay. So I'm going to take a moment and switch over so that you can see what's going on in my calculator. Okay. And remember, to import a data set into your calculator, you need to make sure you do 2 things at the very beginning of this problem. One, you may have old data in your calculator from a previous problem, a previous homework exercise, or a previous test. Let's go ahead and clear the memory of our calculator just to make sure that we have a fresh, clean slate. So I'm going to hit second, and then memory, which is the plus button. Then I'm just going to hit 7 to reset, 1 for all RAM, and 2 for reset. And so I should get this RAM cleared message here that tells me that I'm okay. I've cleared the memory from my calculator, so none of the previous things I've entered in the calculator should affect me. Okay. I'm also going to come down here and write problem number 3. Okay. So to enter data in your calculator, remember, you just need to hit the stat button and hit enter for edit. And we are literally just going to take the time to type in all of that data into our calculator. Okay, so just make sure that you're being very careful. There are 40 values here. If you mess up one of them, you could throw off your entire problem. So we have 480, 503, 514, 472, 465. Okay. And I'm just typing in the number and hitting enter to get to the next line. I'm going to switch back to the data set so that you can see what numbers I'm typing in. Okay. So we did that first line. We're on the 6th one, so the next line. So we're doing 473, 475, 500, 502, 506, 492, 477, 483, 475, 481, 512, 473, 488, 485, and 503. That should be the 20th. Okay, we're halfway through. 508, 484, 486, 499, 512, 485, 468, 507, 501, 470, 497, 479. Easy to have a moment of dyslexia there. Okay, now we're at 492, 468, 492, 466, 472, 483, 511, and then 481. Okay. So when you type this into your calculator, you should see that in your list, you should have 40 items in the list. So that means that this blank item that we could enter as our next data point, that value would be the 41st thing in the list, but we're not going to do that because we only have 40 data points. Okay, so now that we've typed that into our calculator, we need to make sure that we sort that. Okay, so I'm going to go ahead and hit second quit, and we're going to go back to stat and use the sort ascending option. That's the second option because we want it listed from smallest to largest. That'll make things easiest for us. So I'm going to put sort A, and then I need to go down here and click on second, and then 1, so that I have list 1 entered in that function. I'll hit enter, and when it says done, if I look back at my list, it will be sorted. Okay, so it'll be in order from smallest to largest. So I go back to my list and edit just to view it. So we now know that the minimum value, I'm going to zoom out. The minimum value of our data set is 465. And the maximum value, the highest value, I just go up a couple times, is 514. Okay. So that's the first thing that you want to do is sort the data. Okay, and the reason why I'm getting the min and the max is because to construct that frequency distribution, the first thing that we want to do is find the class width. Okay, and with this one, the class width is going to be based on the range divided by the number of classes that the problem asks us to use, and then we're going to round that up. Okay. Okay, so if you've never seen these symbols before, this symbol that looks like a box that has these little tabs on the top only is a way that mathematicians say round your answer up. Regardless of what the decimals are, you're always just going to round that up. Okay, so let's see. Our range is just going to be 514 minus 465. And then we need to read the problem again just to see how many classes they wanted of us. So it says use 6 classes. So the problem specifically told us to use 6 classes. And then whatever we get here, we need to round up. So I'll just go back to my handy calculator. 514 minus 465. Divide that by 6. That comes out to 49 divided by 6, which comes out to 8.1667-ish. Okay. And then we're rounding this up. So that should just come out to 9. Okay. So this is our class width. Okay. I'm just going to give you guys a moment to sort of emotionally catch up with that. If that made sense, then you should be okay. The next thing that we want to do is find the class boundaries. So we want to find the class boundaries using the class width we just found. And we want to start at the bottom, right? Start with the lowest value that you had in your data set. So we're going to start with our minimum, which was 465. And we're just going to add the class width to get the next lower class boundary. Okay, so I have think about making a table here. Classes. We have 465 to God knows what. But to get to the next lower boundary, which would be right here, we're just going to add our class width, which is 9. Okay, so 465 plus 9 should give you 474. Okay. Now we can do this again until we have a total of 6 classes. So we'll have to go up to add 9 there. So that's going to be 483. Add 9 again. 492. That's only 4 classes. We should get to plus 9. 501. 1, 2, 3, 4, 5. And then our last one will be plus 9, which is 510. Okay. So those are our lower boundaries, lower bounds. And now we have to find the upper bounds. Well, the upper bound has to, at least for this last class, has to end at our highest value, which was a maximum of 514. Okay. So I think the easiest way to fill this in is that this number that goes here on the first class is just one below this 479. So one number less than that would be 473. And then the same thing here to get to the next upper boundary is that we should just be able to add 9 until we get to the next one. So this next class should be 473 plus 9, which should be 482. And there's a lot of like little things that you can do to check yourself. For instance, if I just look at this next lower boundary, 483, and just subtracted 1, well, I get 482, which should be correct. Okay, and I could do it either way. I could just count down 1 from that the next lower boundary to get the upper boundary. So like if we look at 492, this one should be 491. But I can also just continue adding 9 to what I had before. However you want to think about that. Okay, so this one should be 500. This one should be 509. And then if we think about this for a moment, okay, we have 1, 2, 3, 4, 5, 6 classes. Okay, so we should be good there. Okay. So let's turn our attention back to our options here. So we'll look at the problem here, and we should see our class boundaries, lower and upper, should be matching what we see here. So first off, we know that we can take a look at our lower boundaries here. So we should have started with 465 and then gone up to 474. Okay, so these first two options don't seem to work because we need to go to 474 and only the last two options work there. And I'm seeing that I may have made a mistake when I entered the data into the calculator. It's not a huge deal, but the maximum value based on what I'm seeing here, based on these two options, is 518. So I think I may have fat fingered something incorrectly into the calculator. No, that makes more sense actually, because if we add 9 here, we should have gotten to 518. Okay. Yeah. So this isn't necessarily the maximum, because I think in our data set it was 514 for the maximum. But we just go ahead and use that stair-stepping pattern of just adding 9 to each of these, and we get that upper bound for that last class. Okay. Either way, both of these look good in terms of their class boundaries, upper and lower. So the only thing we really have to do is the hard part of counting up the frequencies. Okay. So what we'll do here is switch back over to the calculator so we can look at what we're doing in the calculator. And then the frequency distributions that were given in the answer choices were very different. But for this first class, we're looking at all of the numbers that are between 465 and 473. So let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should be a frequency of 9 unless I fat fingered something. Let me just double count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 473. Okay. And then we have in the next category, in the next class, we have 1. It should stop at 482. So 1, 2, 3, 4, 6, 7, 8, 7, because that one went over. So that should be 7. Okay. And we can count this for all of the classes that we have here. And let's go ahead just to be thorough. The next one should be 43. So it's 1, 2, 3, 6. It should be another 7. Okay. And then we have 1, 2, 3, 6. 1, 2, 3, 6, 7. And then we have 1, 2, 3, 4, 4 in the last one. Okay. So again, some things you want to watch out for here when we complete our frequency distribution is that your numbers might be a little bit off. You might have counted a little bit wrong. I may have made a mistake. I did make a mistake a little bit earlier, but I'm trying to correct that. And if everything goes according to plan, then whatever answer choice that we're looking at should be close. We may be off by a hair, but that's just human error. Okay. So if I look at these two frequency distributions that were given, and those were only two options left, they have the correct class boundaries. And now if we look at the frequency data here, we have 9, 7, 7, 6, 7, 4, which is what we counted. So this third option, we're going to go ahead and let go and let God, check that, and we should be okay. And we can see we have that green check mark, so everything is working out. Takes a little bit of time, but with the calculator, it's so much faster, okay? So maybe try another one of those on your own and see if you can get the same results, okay? Moving on to question number 4. Okay, now question number 4 says, a graphical display of a data set is given. State whether the distribution is roughly symmetric, right skewed, or left skewed. The relative frequency histogram for the sales price of homes sold in one city during 1996 is shown below. So if we look at this histogram, this relative frequency histogram, we can see that it is very symmetric here. We have 0.01 on the left and the right, 0.04 on the left and the right, 0.15 on the left and the right, and then 0.30 in the middle on both sides. That is the most symmetric histogram that I have seen. Remember the definition of left skewed or right skewed. That skew really refers to if we have a long tail on one side of the distribution or another. So for instance, if I wanted to look at a left skew would mean that most of the data is bunched up over here on the right side, but over here on the left side, we have a long tail. So that would be left skewed. Okay. But in contrast, if we had right skew, then we'd have a histogram that is bunched up over here on the left side, and then it has a long, heavy tail on the right side. So we would say that this one is right skewed. The thing you really want to focus on for determining whether it's skewed or not is where is that long tail? If that long tail is on the left, then it's left skewed. If that long tail is on the right, then it's right skewed. But our graph here is perfectly symmetric. So we'll go ahead and check that and then clear these drawings. Okay. Okay. Last question for this video. Okay, so they say construct an ordered stem and leaf diagram for the given data. Okay, now this one I think that they've only given us two options and they gave us the raw data here. So I think that the best bet is to go ahead and throw this into the calculator. And so we'll just go ahead and if you want to, you can clear your list. I can show you the easy way to do that. Give me just one moment. So we'll clear the list from before. So if you are at the first item in your list, if you go up to highlight where it says L1, and then you just hit clear and hit enter, it clears the entire list. Okay, so we've cleared the list, and now we need to get to question number 5, which is the stem and leaf plot that they're asking for. We need to look at the data again, and I'll go back to our data, but I need to type in this data. So I'm going to put 22, 35, 42, 52, 69, 20, 60, 48, 24, 39, 23, and 24. That's the first row that they gave us. I'll switch back to the problem so that you guys can see what numbers I just typed in, where I got these random numbers from. Okay, and I'll do the second row here in my calculator. There should be a total of 24 data values. So 22 is next, then 20, 40, 25, 27, 27 again, 50, 47, 52, 30, 32, and 48. Okay. And true enough, there are 24 data values there. Okay. Now I want to go ahead and sort those. Remember, you hit stat, sort A, and then we have to hit second one to put L1 in there and sort it. So now when we look at the data, it will be in ascending order. So if I go to stat, look at the data, I have 20, 20, 22, 22, 23, 24, 24. Okay, everything is in order. So again, here, what we want to do is sort A, L1 in the calculator. But then we just need to go and look at what kind of values do we have here? Well, we have values that are in the 20s. We have values that are in the 30s. We have values in the 40s, in the 50s, and a couple in the 60s. Okay, so these are going to be the stem part of my stem and leaf diagram. Okay, and the leaf part is made up by the, not the tens place, but the ones place. Okay, so I have 0, 0, because I have two 20s. And then I have 22 twice, so that's two 2s. I have a 23, a 24, a 24. So I'm just putting the one value there. We have 5, 7, 7. Then we get into the 30s. Okay, so we have a 30, so we have a 0. We have a 32, a 35, a 39, and then I'm in the 40s. I have 42, 47, 48, 48. Then I have 50, 52, excuse me, 52. Then I have 60 and 69, okay? All right. So if you excuse that little mistake, then the stem and leaf plot that we need to select should look something like this. So we'll go ahead and switch back over to Alex. And good thing is that we don't have too many numbers to look at here. We should have 20022344577. So that first one is the only one that matches what we have written down on paper. So we're going to go ahead and let go and let God. Okay, if you want to be more thorough, you can check out line by line each of those little stems and leaves in the stem and leaf plot. But I just took a leap of faith there because right away there's a distinct difference between these two options that they gave us, and the first option was the only one that matched what we put down on paper. Okay. So again, just so that we can break up this review into bite-sized pieces, we're going to break this up into a series of videos where we just look at 5 questions at a time, because I know that it's a lot to deal with and you're preparing for more than just this class. But hopefully we'll get through this, and hopefully you find these videos helpful.